So let's have a look at this question where we got a patient who needs to continue their infusion on a gravity giving set. That means initially they've been commenced on a volumetric pump, but now they need to use a gravity fed giving set. The infusion started 1 hour ago, and the order was for 1 liter to be infused over 12 hours. So this 1 liter was supposed to be given for 12 hours, just to keep running for 12 hours or to finish within the 12 hours. The pump was set to infuse 83 mils per hour, and a standard macro drip giving set is to be used once the volumetric pump is taken away. So having a look at this question here, we could say that because we got the order was for 1 liter to be infused over 12 hours, this technically gives you 83 mils per hour. It's like saying rate is equal to volume over time. And because we got our volume here as 1 liter, which is equivalent to 1000 milliliters, you divide by time, which is 12 hours. This should be able to give you 83.33 mils per hour. If you round this one down, will give you 83 mils per hour, which technically is that part where we got that. So this means that for every single 1 hour, the patient will receive 83 milliliters for every 1 hour. And if you're to keep on giving every 1 hour 83 mils by 12 hours, you should be able to give the 1 liter. So the question is asking us to calculate the new volume. That's what the question wants. So in other words, the question is asking us to calculate the new volume. What it means is initially we started with 1 liter, but you've infused for 1 hour, which you are infusing 83 mils. So what we could do is new volume. This one is equal to the original volume minus what you've infused already. So we know that our original volume is 1 liter, which is equivalent to 1000 ml. We never use liters. It's always convert them to milliliters. So we know that was the original volume that was prescribed by the physician. And because it commenced 1 hour ago, and that means from this 1 hour ago, you've given 83 mils because the speed or the rate of the pump was 83 milliliters per hour. So this will say minus the infused volume, which is 83 milliliters. And then if you to use your calculators or just do this as you wish, you should be able to get that 17 milliliters. It's what is left. So this answers our question where they're asking how much volume is left in the bag, or what's the new volume. So the new volume is 917 milliliters or 917 milliliters. That's what's left in the fluid that we started giving 1 hour ago. Part B of this question is asking us to calculate the rate in drops per minute. So what we could do here is we could annotate a few things here and see what we need. I know that we got the new volume. We could say for part B, the formula is normally, what we work with is rate in drops per minute. It's equal to volume. Remember, always the volume was being milliliters, then you divide this by time, and the time needs to be in minutes. For this one, it will change into minutes because the question here, we're doing rate. It's per minute. That's why we need to use the minutes. And the question is asking you to use the minutes as well. So this one needs to be in minutes. Then we'll multiply this by the drop factor. And the drop factor for this one, because we are using a macro drip, will give you 20 drops for every milliliter. For 1 ml, you get 20 drops. So what we can do is, we know that for sure this one here, because we're using a macro drip, this tells me that it will give us 20 drops for every milliliter, for every milliliter, 1 milliliter. And then I could come here and try and work through this one out where you got our volume. Remember, we need to use the new volume here, which will be 917 milliliters. And then we need to get our time. Remember, the time as well will change. The initial time was 12 hours, but we've infused 1 hour. This means 12 minus 1 will give us 11 hours. So we'll come and say the new time will be 12 hours minus the 1 hour that you've already infused, which will give us 11 hours. This will be our new time. Then, because we've done that, we need to find our DF. And in other words, our DF is 20, because over here we know it's a macro drip. It will give us 20 drops per milliliter. This one will change, will never change as long as it's a macro drip. So macro drips will always give you 20 drops per milliliter. So if we were to put these numbers where they're required to be in this formula over here, we just input what we need. At least we got the volume can go there, and then our time can go here, and then we got the drop factor can just go there. So we got what we need. At this point, we could say rate in DPM is equal to volume, which is 917 milliliters. Then our time should be, at this point, our time that we've already calculated will be 11 hours. But we need to change this into minutes. So you multiply by 60. So there's 60 minutes in 1 hour. So we're multiplying by 60 to make these hours, to convert these hours into minutes. So then you multiply by your drop factor, which is 20 drops. That's what we're getting over there per mil. That's what it normally gives you, and this one will convert this into minutes anyway. Then eventually, if you have to use your calculators here, you'll get 27.787 drops. But remember, these being drops, we cannot have points or decimal points. And this being more than 5 over here, or this one being more than 5, it will be a +1 on this side. So our drop factor can be estimated to be 28 drops per minute. Or you could also say, in other words, it's just, 28. It could just be 28 drops per minute, whichever way. It should be correct in terms of what you want to use. And that's what's required for Part B. Thank you.